Hi guys. Okay, so in this video, we are going to be looking at the introduction to chemistry, introduction to matter, the scientific method, the three states of matter, and we're going to look at the pure substances and mixtures and the physical and the chemical changes and the physical and chemical properties of the substances and the transformation of the three states of matter by the change in temperature. So let's get to it. Okay, so here you see that the chemistry as a study of matter is not just confined to the Earth, it is also found in the outer space, in the cosmic world, because matter is everywhere. Matter is what makes the leaves, and chemistry is what gives the beautiful color to these leaves in the fall season. It is chemistry that is responsible for the thunder and lightning and this phenomena in nature. We also see chemistry deep into the oceans. Chemistry is present on your table as a table salt. Oxygen that you are breathing in, you cannot see. The same oxygen can be liquefied into this very beautiful blue colored liquid you see on the right hand side of the screen. Same is the case, the air that you do not see, but that same air you fill in the car tires, and there's a phenomenon of chemistry that goes behind it. Chemistry is present in the Coca-Cola that you drink. Chemistry is responsible for the flight of the hot air balloons. So chemistry, as we see, is a study of matter, and there is a huge diversity in matter in this universe. So chemistry follows certain rules, certain laws, but at the same time, not all the phenomena is going to follow the same rules and laws. There are going to be some exceptions all the time because we are dealing with matter. So that's what makes chemistry interesting. And how do we come up to these rules, regulations, and laws about chemistry? We have scientific principles, scientific methods. And what is that? So I'll show you in a minute. Okay, so first of all, chemistry gets its knowledge from a number of other disciplines. So as you can see on the screen, that chemistry being a central science is connected with all these other sciences: environmental science, biochemistry, chemical engineering, material science, nanoscience, chemical physics, nuclear chemistry, geochemistry, food chemistry, biology, medicine, agriculture, earth sciences, physics, mathematics, computer, chemical sciences, and so forth. So all these disciplines contribute to the understanding of matter, which is punched up into this discipline of chemistry. Okay, so here on the screen, as you can see, this is the scientific method. So how do we understand matter? So we understand that, yes, when we look at the phenomena, we have a question. So that question, we look for the answers in all this huge body of knowledge. As you saw, that chemistry gets its information or its knowledge from all these other disciplines. So we try to seek some relationships and see if we could make sense of that phenomena, or we can find the answers to that. So basically, we look into the theory. Now, in case we are not sure or we cannot find the right answer, then we construct a hypothesis, and a hypothesis is basically an educated guess. Then there are three stages to experiments. One is the steps that you're going to conduct an experiment with. Next is the apparatus, the equipment, the measuring devices you are going to use to capture some data. And the last is analysis of data. Okay, so in this, when we do these steps, if the steps are faulty, we go back and we keep repeating the steps till we get a perfection. Next is we start gathering the data using the apparatus. The apparatus could be beakers, could be test tubes, could be flasks, could be anything. So these apparatuses are used also to measure. Like, for example, for measurements could be like a thermometer reading, or you're just observing, whether this experiment is going to um, cause some kind of, gas formation? Or is it going to give us some heat? Or is it going to capture some heat from the surrounding? So all these, observations, we tabulate them into tables, and then we do trials, and sometimes we change the variables, and then we look at the data, we analyze the data, we look at the data points, we see the patterns. Are all these the same? Are all the data points close? Is there, how much of the data is precise and how much of it is accurate? Those things. And then we look at some of the data which do not follow the norms. Are they outliers? And these outliers, then what do? We go back and we rebuild our hypothesis. We try to understand this exception to the, norm. So we try to like figure out then why is that certain data points are agreed to a certain situation while others don't. So that leads us to, some kind of exceptions to the rules. And if all the data points we get consistency in those, whenever we repeat the experiments, then that gives us like there seems to be some kind of a law, that is associated with that phenomena. So this is how we get to, conclusion regarding our understanding of the matter. Okay. Okay, so now we're going to look at the three states of matter, solid, liquids, and gases. Okay, so there are three states of matter: solids, liquids, and gases. So what are the properties of solids? Solids is that part of matter which has a very definite shape, has a definite volume, and the particles are very close together and they are arranged in a very fixed patterns. Okay, and these particles move very slowly. Okay, liquids, on the other hand, they do not have a definite shape, but they do have a definite volume. So regardless, volume is basically the amount of space an object occupies. Okay, and then we take these liquids, we see that what is the situation with the particles. The particles are fluid, they're mobile, they move, and the particles, they are, they are mobile and they move, very slowly. But on the other hand, the gas, now what about the gases? The gases, these are indefinite shape, indefinite volume, because they like to expand, but at the same time we can contract the gases also. Okay, they take the shape of the container, the particles are very far apart, and the particles are always constantly moving. So these are the basics of the three states of matter. Now we're going to look at um, the uh, the physical properties and the chemical properties that define the matter. So anytime you look at anything that is solid, anything liquid, or anything gaseous, then we say like, okay, does it have like, what does it look like? What does it feel like when you touch it? How does it taste? How does it smell? How does it, feel like? Does it conduct electricity? Does it conduct heat? Does it conduct light? Is it soluble in water? Is it insoluble in water? At what temperature is it boiling? What temperature does it melt? What is the physical state of it? What is the shape of it? What is the color of it? So all these are physical properties. And then there are more. Density, is also one, whether it sinks in water, whether it float in water, those things. So here is an example of a physical properties of copper. Okay, this is an example. So the color of copper, brownish, shiny, right? It's an excellent conductor of heat, excellent conductor of electricity. It is solid, okay? It's melting at 1083 degrees Celsius, which means that it is going to go from this solid state to a liquid state. Then it boils at 2567 degrees Celsius, which means that it is going to from a liquid state to a gaseous state. So that is the situation with, when we define something from a physical perspective. Okay, then comes the physical change. Now physical change is just a temporary change, it is not a permanent change. So here is a state of a picture of a salt for salt farm. They take the saline water, which is basically the water has large contents of salt, and they evaporate it. So basically the water, which is in a liquid form, and it turns into vapors, which is again water, but what we see here is the salt, and the salt is in the solids condition, is, it separates out. So physical change is a change of state in which the water changed from a liquid to a gaseous state. The changes of it just changes the physical shape, Okay, so liquid goes to a gas state, solid that was soluble in the water now begins, you can see it in a crystalline form. Okay, but in this, in a physical change, the identity and the composition of the substances does not change. Okay, and evaporation is a process that leads to that physical change. Okay, it's a physical evaporation of water from the sea water will it's a physical process. Okay, now let's look at some of the examples whether you can um, understand the physical changes. Like for example, water boiling to form water vapor. Okay, the water is boiling to form water vapor. So that is just a physical change, because you can capture the water vapor and you can convert it back into a liquid. Sugar dissolving in water to form a solution. Okay, so that is again a very temporary thing. Copper made it into thin wires. That is again a change of shape. Paper is cut into thin pieces, you know, that is again the change of shape. Pepper is ground into flakes. So every single flake that is left is still pepper. So although the shape has changed, you know, the look is changed, but it is still the same. Okay. So these are the physical changes. Now let's look at the chemical properties. Chemical properties of the substances are the ability of the substance, to form a new substance. So that is a chemical property. So when substances react, are they going to produce, what kind of new substance are they going to produce? Are they even going to produce the desired substance or something else? Or are they going to produce heat? Is some gas is going to be evolved? Or fizzing is going to be heard in the chemical reaction? Are we going to see some solid suspended in a chemical reaction? So anytime, you know, chemical properties are like, what would be the reaction of the substance? So not all the substances are going to react the same way. So chemical properties, again, are very unique to that particular substance. Okay, so anytime a chemical change happens, a new substance is formed every time. Now, for example, here you have a sugar, you caramelized it. Okay, caramelize it, you take sugar, you heat it, like you just rub it over a hot, like a pan, and it turns into like charred sugar, like a brownish sugar, but still it is a different, it's not the same as the previous sugar. So the sugar, the composition changed, you know, so every time something new is formed. So this is a chemical change. Now let's look at some of these examples. Now let's say a silver, like a jewelry, and once it becomes brownish or darkish or blackish color, grainy, that means it has gone through some kind of a physical change. Wood, a piece of wood that is burning in a fireplace, that piece of wood, fire, carbon dioxide is evolved, water vapor is evolved, and it vanishes in the air. Still, it is a chemical change. Okay, heating of the sugar to form a caramelized sugar, chemical change. Iron getting rusted, brown grayish colored iron reacting with oxygen to form orange red rust, chemical change. So chemical changes are permanent changes. Okay, so now let's look. All right, so here on the screen, you see that you can change solid, liquid, and gas. All these different phases can be changed by changing the temperature. And there is a name that goes with this phenomena. So just in your mind here, imagine ice, water, and water vapor. So let us say ice, which is a solid. So how can you convert the solid ice to water, liquid? So here is your ice, and here's your water in the liquid form, and here's your water in the vaporized form or water vapors. Okay, so you take ice and you bring it at room temperature, or you increase the temperature. So when you increase the temperature, then the ice begins to melt and it converts from a solid to a liquid state. Now you take that liquid water and you heat it. So when you heat it, what happens at boiling, when it begins to boil at a high temperature, it converts into gas, which is the water vapor. Now the same water vapor can be converted to a solid by bringing the temperature down, and that, oops, sorry, and that phenomena is called solidification. Okay, that phenomenon is called solidification, and that happens in the cold temperatures, especially, when it's snowing outside. You see the water vapor is going to strike the glass of the window, and it forms those beautiful, structures of ice. So it's frozen, it immediately freezes, okay, the water vapor. So that is solidification. Okay, now let's look at the gas. Can be converted into a liquid. The same gas, which is in the form of water vapor here in this case, can be converted to a liquid water by condensation. So this thing we see all the time, the cold water bottles, when we bring them out into the room temperature, then we see outside there is a beading of water. We see it becomes wet. And why does it become wet? Because the outside atmosphere, there's water vapor in the gaseous state. And when they strike the cold surface of the bottle, immediately there is a change of phase from a vaporized state to a liquid state. Next is, how can you convert liquid to a solid? Certainly by freezing, which we know it. We bring the temperature down and the liquid freezes to the solid. So water freezes to ice. Now the last one is sublimation. Now you take the solid and you can directly convert it into the gas. In other words, you take solid and you can heat it, or bring it to a room temperature, and then it can convert to gas. Like, for example, carbon dioxide. So carbon dioxide in the form of pellets is dry ice, right? And so this solidified carbon dioxide can be converted to the gaseous carbon dioxide by leaving it in the room, at the room temperature. Similarly, ammonium chloride. Ammonium chloride is solid at room temperature. It's a salt. It's like a solid powder. And when you heat it, and after some time, when it heats, it doesn't melt, but it directly converts to a liquid, solid. It directly converts to a gas. I'm sorry. It converts to a gas, and then in a vapor state, and then it changes directly from a solid to a gaseous state. So with that said, just bringing the change in temperature, you can bring about a change in transformation from solid to liquid, liquid to gas, and so forth. And this is all the interesting stuff about matter. And I hope you found it easy. And thank you so much for watching. Take care. Bye-bye.